Hi, in this video we will do some examples for the limit laws. For example 1, we have two functions whose limit as x approaches to 2 is given. For f it is -1, for g it is 3. We don't know what are f and g, we only know they have limit and the value of their limits are known. So here, for the first part, we are looking for limit of f of x minus 5gx. Well, since we know the limit exists on each part, we can use the difference law, and then we can separate the limit of f of x and limit of 5gx. As x goes to 2, then for the second part, actually we can take this constant out of limit. This is called constant multiple law. Yes, so it means that we have limit of f of x as x approaches to 2 minus 5 limit of gx as x approaches to 2. Now we are down to the values of the limits of these two functions. The limit of f of x as x approaches to 2 is -1 minus 5 times limit of gx is 3. This gives us in total -16. For the second one, we have a second root of x fx plus gx as x approaches to 2. First, we need to check if the limit of the function under the square root is a positive number or not. So here we apply again sum law. This gives us limit of x, f of x, as x approaches to 2 plus limit of gx as x approaches to 2. Then we will have a limit of, this is two functions multiplied, so we can find the limit of product by product law. And that will give us limit of x as x approaches to 2, limit of f of x as x approaches to 2 plus limit of g of x as x approaches to 2. While limit of x as x approaches to 2 is 2 times limit of f of x is -1 plus gx is 3. This gives us 1. And since it is positive, we can apply the root law here. And this will be limit of x f of x plus gx. First find that as x goes to 2, then find the square root. And we already found that this is square root of 1, and that gives us the value of that limit, which is 1. For the third one, we have quotient, so we need to apply quotient law, but first we should make sure that the limit of the denominator, which is this, is non-zero. And it is because using the power law, we have a limit of gx to the power 2 as x goes to 2, and that is 3 squared, which is 9. So since the denominator has non-zero limit, we can now use quotient law. It means that we can all separately apply the limit to the numerator and limit to the denominator. Let me just take this a little bit down here. Okay. And limit of the denominator gx squared. While applying proper laws here, I will get 1 minus limit of f of x as x goes to 2, and then limit of gx squared as x goes to 2. And this gives us 1 minus negative 1 over 3 squared, which is 2 over 9. And well, that's how we find those kind of limits. Example 2 is a little bit different. But it says that find values of a for which the following function has limit at as x approaches to 1. So we have to remember that the limit exists at a, so limit of f of x as x approaches to a exists if and only if the left limit exists, right limit exists, and they are equal. The reason that we are going toward the left and right limit, because this function is piecewise defined, so we can find limit of the function at the point which separates the pieces of the domain by left and right limit. So this is limit of f of x. So let's just do the left one. As x approaches to 1 from the left, it means that while x is going to be less than 1 always, and less than 1 means that we can apply this formula for the function over there. So it will be x squared minus 2 over x squared minus x plus a. And then here we can apply the quotient law and then just apply x squared minus 2, x goes to 1, and limit of x squared goes to 1, x squared minus x plus a, while assuming two things, that the limit of numerator and denominator exists and they are non-zero, yes? So here I also did something else, that I can turn negative x approaches to 1 from the left to just limit of x, because I know that these are polynomials and their limit exists. So the limit and the left limit are going to be equal. So here this is direct substitution, 1 squared minus 2, 1 squared minus 1 plus a, and that gives us negative 1 over a. Here we are assuming that a is non-zero, otherwise we are in trouble. The quotient law we cannot apply. Well, okay, so that's the left limit. How about the right limit? Well, this means that x approaches to 1 from the right, or from the values greater than 1. So we will have limit of just this formula, the formula which is for values of x bigger than 1. And this is polynomial. It has a limit. And since it has limit, the left limit and the limit itself are going to be equal. And then direct substitution. For polynomials, limit and direct substitution gives us the same thing. So this is a plus 2. So we found the left limit is negative 1 over a. Right limit is a over a plus 2. To have limit at x approaching to 1, we have to make sure that these two are equal. Left and right are equal, yes? So it means that negative 1 over a needs to be equal to a plus 2. As a result, negative 1 equals to a squared plus 2a. And then we have a squared plus 2a plus 1 equals to 0. This is a quadratic equation for a, and actually we can do this decomposition, and we get a plus 1 is equal to 0. As a result, a needs to be negative 1. And well, that shows that if a is negative 1, then the function has limit at 1. And one thing important here is that this piece x equal to 1, since we are just studying the limit, we don't care what is that piece. When you're studying the limit, you don't consider the value of the function at that point. So these were the examples for laws of limit.